Hey everybody. Okay, today we are going to be working on fractional equations. Now, fractional equations are things that look like this. So we have over here, 2x plus 1 over 3x plus 4 is equal to x over 3x minus 2. Okay, so this is a fractional equation because I know we've solved equations with fractions before, but now we have variable expressions in our fractions, in the denominators even. Okay, and that's a little bit of a problem for us. So what I'm going to do here is I'm just going to kind of work this out, and I'll make some points as I go along. So the first thing we're going to do is we're going to approach this just like we would a normal equation. And we want to cancel out the denominators. That's what gets in our way here. So we're going to cancel out these denominators. Let me move this a little bit more. And the way we do that is by multiplying by the least common multiple of these two denominators. Now, these two things, these two denominators, are kind of like factors all to themselves. So what we're going to do is we're going to multiply by 3x plus 4 times 3x minus 2. Okay, so we are going to multiply both sides of this equation. I'll do it like this. And we're going to multiply both sides of this equation just like this. So this is just like if we were adding these two fractions, what would our least common multiple be to put in the denominator? Well, because these two things here are kind of like their own factors, we'd have to multiply them together. So that's what we're going to do. Okay, now something interesting happens here. When I multiply across like this, let's see here, the 3x plus 4 is going to cancel on this side. So I'm really multiplying 3x minus 2 times 2x plus 1. Make sure you put these in parentheses. You can't just distribute the 2x. You have to multiply these two binomials, so either FOIL or do the long multiplication. And over here, the 3x minus 2 is going to cancel. So I'm left with x times 3x plus 4. Now this one I can just distribute. Okay, so let's go down here. And I still have my equal sign here. 3x minus 2 times 2x plus 1 is equal to, I'll just go ahead and distribute here. So this is going to be 3x squared plus 4x. I just distributed the x to the 3x and the positive 4. Okay, now I hope you can see that this is kind of like a quadratic, like we've already done many times before. So we're going to multiply this through. We're going to expand this expression on the left side of the equation. And that's going to be 6x squared, let's see, minus 4x plus 3x, so minus x minus 2. And because these are two binomials, I'm doing the FOIL method in my head. Let's see, and over here we've got our 3x squared plus 4x. Okay, this is a quadratic, so what we want to do now is we want to get a 0 on one side, so I'll go ahead and subtract 3x squared and 4x from both sides. Just going to subtract this over. Oops. Okay, I'm going to have to move this stuff. So what we get now is 6x squared minus 3x squared is going to give me 3x squared. X minus 4x is going to give me minus 5x. And then I still have this negative 2. And this is equal to 0. Okay, so now I need to factor this thing. And once I factor it, I'll set those two factors equal to 0. Now, this is going to be a box method factoring. Okay, I'm going to shrink this down a little bit. Move this out of the way. Should have done the whole thing, but that's fine. Okay. So we would go ahead and we would do the box method. Now I'm not going to do that because you've done that a bunch of times. So I know that this is going to be 3x plus 1 times x minus 2 equals 0. And we can check just by FOILing. So let's see, 3x times x is 3x squared. 3x times negative 2 is negative 6x plus an x. That gives me my negative 5x. And then 1 plus negative 2 is negative 2. If you're not comfortable with that, you can review the box method. Okay, and then all I'm going to do is set these two things equal to 0. So if 3x plus 1 is equal to 0, actually we've done this 100 times, so I'm just going to go through and give the solutions. X would be, here, to make this 0, it would be negative 1/3. And to make this 0, it would be a positive 2. Okay? So, what we have to do now, this is what makes fractional equations special. First of all, going through all these steps, we haven't really had to do that much work for an equation before. But the next step is to check, to plug these back into the original equation. And the reason why is because we can't have zeros in our original equation in the denominator. Okay? So when I have 2x plus 1 over 3x plus 4 if I plug one of these numbers in these denominators and I get a 0, that's a problem. Okay, that's something we can't do. Remember, we can't divide by 0. So let's just do this by inspection. Negative 1/3 times 3 is negative 1 plus 4 is 3, so that's good. I'm okay there. 2 times 3 plus 4 is 10, so I'm good there. Negative 1/3 times 3 is negative 1, minus 2 is negative 3, and then 2 times 3 is 6, minus 2, which equals 4. Okay, now I didn't have room for doing all that calculation there, but all I did was substitute these things in my head. These do not produce 0 denominators, so these are our solutions. Now, if one of these did produce a 0, we would just cross it out and say that's not a solution. If both of them produce zeros in the denominators, then this equation wouldn't have a solution. But for now, these are the solutions. Okay, I hope that helped. If you have any questions, let me know in class. Thanks.